Hello friends. In this video, we'll take a look at an interesting device, the LinknLink eMotion Pro. It combines several features in one. An infrared blaster that emulates remote controls for various household appliances and allows you to control them via your smart home. A presence sensor based on a 24 GHz microwave radar with the ability to divide the detection area into separate zones, each configurable individually. A light sensor that complements the presence sensor in lighting automation scenarios. In this review, we'll cover the main capabilities of the device, explore the control and setup app, and integrate the LinknLink eMotion Pro into the Home Assistant smart home system. And before we begin, as usual, please give this video a like and leave a comment below. It helps with YouTube's algorithms. If you're not subscribed to my channel yet, now is the perfect time to do it. Model: LinknLink eMotion Pro. Device type: combined presence and light sensor, infrared blaster. Interface: Wi-Fi 2.4 GHz, Bluetooth 4. IR transmitter frequency: 38 kHz. Range up to 15 meters. Maximum detection range: up to 7 meters. Sensor coverage angle: 150 degrees. Works through obstacles. Size: 61 by 61 by 25 millimeters. Power: USB-C. The device comes in a white cardboard box with an image of the unit on the front. Also displayed are the manufacturer's logo and the Motion 2 mqtt logo. One side of the box lists brief technical specifications, which I've already mentioned. You'll also find the manufacturer's name and production address there. The package includes the sensor itself, a power cable, and a small instruction manual. The manual is provided in 8 languages. It includes the key connection parameters, technical specs of the device, and a link to download the control app. The sensor has a round shape with a diameter of 61 millimeters and is made of glossy white plastic. The package also includes a stand for mounting the device to a wall or ceiling using 3M double-sided tape. On the back, near the power port, you'll find the model name and number, power requirements, and the serial number. The unique design allows the power cable to be connected in a way that keeps the connector aligned with the main surface of the device. As a result, the cable does not stick out and does not increase the overall dimensions of the unit. The package includes an adjustable stand for mounting the sensor to a wall or ceiling. Both sides of the stand are equipped with 3M double-sided tape. One side is for attaching to the surface. The other is for attaching the sensor itself. The mount design allows you to adjust the sensor's tilt angle, making it easier to install in the optimal position depending on placement and desired detection area. Using the QR code in the manual, I go to the download page for the control app, which is called LinknLink. After installation, you need to select your country and either log in or create a new account if you don't already have one. To begin installing and registering the device in the app, press the Add New Device button at the bottom of the screen. Next, review the terms of use and confirm your agreement by clicking Continue, then choose Add New Device in the next menu. In the next window, I select the top option, E-Series Hubs and Sensors. Then, from the list that appears, I select the bottom item, which is for adding eMotion Pro, Max, and Ultra series devices. This launches the setup wizard, which tells you to turn on the device and wait until the LED on the bottom starts blinking, indicating it's ready for pairing. The initial connection is done via Bluetooth, so make sure Bluetooth is enabled on your smartphone before starting. Next, you need to enter the name and password for the 2.4 GHz Wi-Fi network that the sensor will connect to. The app then connects to the device over Bluetooth, sends the Wi-Fi credentials, and the sensor connects to the network. In the final step of pairing, you'll need to specify the device's location. The wizard offers a list of standard room names, e.g., living room, bedroom, kitchen, etc. After that, you can assign a custom name to the sensor, which will be displayed in the app. With this, the setup is complete, and you can start using the device. This is a combo device, so after pairing the main module, you need to separately add its built-in sensors, presence, and light. The first to be added is the presence sensor. To do this, select the room where it's installed again and optionally assign a name. Next, a page appears showing the functions of the connected subdevice. As you can see, in addition to presence detection, there are 4 separate zones available. We'll discuss their purpose and configuration in detail later. Then, a note appears indicating that this subdevice depends on the main module, the LinknLink eMotion Pro sensor, which must be powered on and connected to the network. After this, the final step of the setup and a message confirming successful addition of the presence sensor. It is now fully ready to use. A brief installation guide for the sensor is also shown, describing and illustrating in detail how to correctly mount the sensor on the wall, its detection zone layout, and important placement recommendations. The device should not be placed near power cables, behind appliances, or blocked by metal objects, which may interfere with the radar's proper operation. On the app's main screen, you'll now see 2 entries: the main eMotion Pro device and its subdevice, the presence sensor. Tapping the presence sensor line opens its plugin. Here, you can see the current sensor status. If no motion is detected, an appropriate message is shown. If motion is detected, a person icon appears in one of the zones, depending on the distance to the object. We'll talk more about the presence sensor's operation a bit later. For now, let's go back to the main device, eMotion Pro, and move on to adding the second subdevice, the light sensor. The pairing process is exactly the same as with the presence sensor. Select the room. If needed, you can assign a custom name for the light sensor. Then the familiar note appears again, reminding you that the subdevices depend on the main eMotion Pro unit. Next, a confirmation message appears showing the new subdevice has been successfully added. The light sensor is now ready to use. Now the main screen shows 3 entries. The third element has been added, the light sensor. When you open its plugin, it displays the current light level, measured in lux, 3 light level thresholds, which you can set manually right here, as well as a timeline graph showing light level changes throughout the day. This allows you to track lighting dynamics and use the data in automations. I was eager to test how the sensor would work with Home Assistant, so I decided to connect it right away. To do this, go to the plugin for the main device, eMotion Pro. By the way, at the top of this window, you can see the current status of both connected sensors, light and presence. But what we're interested in is the button with 3 horizontal dots in the top right corner. Tap it, a small menu opens. In it, select the mqtt connection option. This button opens the connection settings menu for the mqtt server. In the Home Assistant system, the most commonly used add-on is Mosquito Broker. I explained how to install and configure it in detail in a separate tutorial, and I'll leave a link to it in the description under this video. Here in the LinknLink app, we need to specify the IP address of the mqtt server. It matches the IP address where your Home Assistant is installed. The port number, by default, it's 1883. If you haven't changed it, enter this value. The login and password that you set when configuring the Mosquito Broker. After filling in all the information, tap the Save button in the upper right corner. If the connection is successful, a line labeled mqtt connection status will appear at the bottom of the window, and it will say Connected, which means the connection has been established. Just in case, let me remind you where exactly in Home Assistant you set up the mqtt broker login and password. Open the Settings section, Add-ons, Mosquito Broker. Go to the Configuration tab. This is where the connection parameters are defined in the YAML config. Once the connection with mqtt has been successfully established, Home Assistant will automatically detect the new device. It will appear in the list of devices in the mqtt integration section and will be added as a new device without the need for manual configuration. In the left column of the Home Assistant interface, you can see that the device is identified as eMotion Pro from LinknLink and is connected via the mqtt integration. However, at this stage, the list of available entities shows only the presence sensor, distance to the object, and the presence event type. But in fact, only two sensors are working in Home Assistant: presence detection and object distance. In the screenshot on the right, you can see the device status in the LinknLink app at the same moment. It also shows the event type. In this case, it's moving away from the sensor, but this parameter is not currently passed into Home Assistant and is not displayed as a separate entity. Let's return to the LinknLink app and explore other options from the same menu. The first one is backup. It is intended for creating a backup copy of the settings, but as far as I understand, it only concerns the IR Blaster settings, and only if it was previously configured to work directly from the app. I'll show how exactly this function works a little later. At the moment, after creating a backup, no save files appeared in the Backup Restore section. The Convert to Home Assistant panel function is somewhat unclear. In the case of eMotion Pro, it apparently doesn't work, since no available options for conversion are shown. Perhaps this function is intended for other device types. In the meantime, let's go to the Settings menu to check for firmware updates. This is especially relevant because possible issues with sensor display in the Home Assistant mqtt integration may be due to outdated firmware. As you can see, the current firmware version is significantly outdated. Moreover, the changelog of the new version mentions fixes related to parameter display in Home Assistant. Let's perform the update and see if new entities appear and the integration improves. The firmware updates fairly quickly. The device uses Wi-Fi, which transfers data much faster than Zigbee. Once the update is complete, an installation log appears showing key events in the process. By the way, you can also see the IP address assigned to the device by your router. Now the firmware has been successfully updated. The current version at the time of testing is 61061. The firmware update really fixed a lot. Now, in the Sensors section, in addition to presence detection and distance to the object, a new value has appeared: brightness level. This means the light sensor is now correctly passed to Home Assistant. In addition, the Events menu now shows typical presence sensor events. For example, in this case, you can see the approaching event, which previously was not passed into the system. After the firmware update, additional sensor settings also appeared, which we'll look into a bit later. Also, the signal level of the Wi-Fi network the device is connected to is now displayed. This is a useful parameter, especially if you plan to place the sensor at a significant distance from the router. It will help assess connection stability. Let's review all the entities that were passed into Home Assistant via mqtt integration after connecting the LinknLink eMotion Pro device. The first entity is the presence sensor. It has two states: presence detected, no presence detected. The next entity is the light sensor. It transmits a numeric value of the illumination level in lux. In the Home Assistant interface, you can also view a history of this value's changes, which allows you to track how lighting changes throughout the day. Based on this data, useful automations can be created. For example, to turn on lighting only when the light level is low, not just when movement is detected. The next entity is the object distance sensor. It shows the distance at which movement was detected in meters. This allows not only to determine the fact of presence, but also to estimate how close the person is to the sensor. The next entity is the presence event type. I was able to identify 3 event types: moving away from the sensor, approaching the sensor, just detecting presence, without a change in distance. Next are the settings that allow fine-tuning the device's behavior. The first one is Light Level Reporting Interval. It determines how often the sensor will send data about the current illumination level to Home Assistant. The value changes in 10-second increments, and by default it's set to 10 seconds. The next setting is the Brightness Change Threshold, sensitivity to changes in illumination. It is measured in lux, and by default set to 5. As I understand, this parameter defines how much the illumination level must change for the sensor to forcibly send a new value to Home Assistant, regardless of the reporting interval. The next setting determines the sensor mounting type and is implemented as a drop-down menu with 3 options: ceiling mount, 3-meter height, optimal for even top-down coverage; wall mount, for short distances, used in small rooms or areas with limited detection depth; wall mount, for long distances, intended for long hallways or open spaces where extended detection range is important. The next parameter is the object detection distance threshold, measured in centimeters. By default, it is set to 50 centimeters. As I understand it, similar to the brightness threshold, this is the value by which the distance to the object must change for the sensor to send updated data to Home Assistant. In other words, if the distance to the object changes by 50 centimeters or more, a forced transmission of a new value occurs, even if the reporting interval has not yet expired. Now let's move on to exploring the capabilities of the featured device. We'll start with the infrared blaster function. Let's try adding a new remote. To do this, we press the corresponding button, which opens the Device Edition menu. Devices are sorted into categories: TVs, air conditioners, media players, fans, lamps, and others. Select the appropriate category. For example, I chose TV. In the next menu, a prompt appears asking where the remote will be used, either for Home Assistant via mqtt, or for control directly from the LinknLink app. In the next menu, there are 3 tabs for adding a remote. Official. Here you can select a ready-made remote from the database by brand name. This is the fastest method if your TV, air conditioner, or other equipment is officially supported. Custom. Designed for manual addition via learning mode. In this case, you use the original remote to transmit commands to the IR blaster, training it. Restore. The tab for selecting a previously saved backup, which I mentioned earlier. If you've added a remote in the past and backed it up, you can quickly restore it here without reconfiguration. If your device is officially supported, it's simple. Select the brand, then the device model, and that completes the addition. The commands will be automatically loaded. If your device is not supported, you need to press the button at the bottom of the screen for manual IR blaster training. In this mode, you will transmit signals from the original remote, and the blaster will memorize them for future use. After that, specify the room where your infrared blaster is located. In the next step, you need to specify a name for the device being added. I left the default value, TV. As you can see, the Home Assistant logo appeared on the TV icon in the bottom right corner. This means the remote will be used via mqtt integration in Home Assistant. Then the familiar Subdevice Usage Terms tab will open again, which we saw when adding the sensors. After confirming, a remote template will open, a layout with buttons, each of which is currently inactive, displayed in gray. In the app, tap on the image of the button you want to train with the original remote signal. Then press Start Learning. Bring the original remote as close as possible to the IR blaster and press the desired button. During training, the LED on the side of the device lights up, indicating it is in receiving mode. When the blaster successfully receives a command, the LED turns off and a message appears stating the signal was accepted. After that, you can immediately test it. Tap the Train button in the app, and the controlled device should respond to the command. After sending the signal, the training wizard asks, "Did the device respond to the sent signal?" If yes, tap Yes. The training is considered successful. If not, tap No and try the procedure again, perhaps moving the remote closer or pointing it more accurately. After successful training of a button, it changes to black in the template. This means it is active and ready for use. You can now proceed to train the next button. This is what a completed, trained remote template looks like. I added all the main buttons that were on the original remote. Now each of them is active and available for use in the app. In the General Device menu, another line has appeared, TV, with a remote control icon. It is also shown in the eMotion Pro plugin as one of the subdevices. Next to it, there is a plus button that allows you to add one or more additional devices, which can also be controlled via infrared signals using the same blaster. Since when adding the remote I selected that it would be used with Home Assistant, a new device automatically appeared in the mqtt integration with the same name, TV. It includes 11 entities. Each of these 11 entities in Home Assistant corresponds to a specific button that we previously added during the remote training process. Pressing any of these buttons results in the corresponding infrared signal being sent via eMotion Pro. Thus, we can now control our device both manually via the Home Assistant interface and use these buttons in automations, for example, turning on the TV when arriving home, switching input when launching a media scene, and much more. Let's now take a closer look at the data transmitted by the presence sensor in the app. At the top of the plugin, the current detection status is displayed. In our example, it's motion detected. Below that is the distance scale, which visually shows that the object is located within the 2-meter zone. Underneath is a timeline that will display the history of sensor activations. Next is the current status. In our case, it's active, meaning presence is detected without active movement. The distance to the object is also shown here. For example, 0.7 meters. Below begin the settings for the 4 detection zones, which we'll go over in more detail later. And finally, there are the following parameters: detection interval, status update frequency, and alarm notification settings. At the very bottom is the sensor sensitivity parameter. It determines how actively the sensor will respond to movement within the detection area. Let's take a look at the detection interval settings menu, which includes several options. By default, the interval is set to 1 minute. This means that after the last detected movement, the sensor will switch to the no motion status after 60 seconds. Additionally, it's possible to configure up to 3 separate time periods, each of which can be set within the 24-hour range, from midnight to 23:59. By setting the necessary time zones, for example, daytime, from 8 to 2300 hours, and nighttime, from 23 to 8 o'clock. You can assign different detection intervals for each of them. In my example, during the day, the interval is set to 1 minute. At night, 15 seconds. This allows you to, for example, have lighting automations turn off faster at night than during the day, which is especially convenient for bedrooms or hallways. In the screenshot on the right, you can see an example of this setup: day mode, 1 minute interval. In the alarm notification settings section, you can define the time range during which the sensor will send alerts when motion is detected. For instance, you can set a daytime period when no one is home, and during this time, if motion is detected, the sensor will send a push notification in the app. The sensitivity of the sensor can also be configured here, with 3 levels to choose from: low, normal, high. Let's take a closer look at the detection zones available in the presence sensor settings. These zones are separate logical areas located within the overall radar detection field. They are not directly tied to the main presence status and are triggered only when movement is detected in a specific part of the space. There are a total of 4 zones available, and for each one, you can assign a custom name. For each zone, you can configure the distance at which it will be triggered. This is done by selecting one of 5 preset ranges from 0 to 6 meters. You can also choose a specific color for the visual representation of each zone. This helps you easily understand the coverage map in the app. In my example, I named the zone Desk. It will trigger when movement is detected at the desk within a radius of 2 meters and is marked with an orange color. Each zone has separate behavior settings that allow you to fine-tune when the zone should activate or deactivate. Absence interval, the time that must pass since the last detected movement before the zone switches to no presence. Presence interval, the minimum time that presence must be continuously detected for the zone to switch to an active state. These parameters help filter out unnecessary or accidental triggers. For example, if someone quickly walks by and no reaction is needed. Here's an example of the settings for the first zone, which will respond to presence within a radius of 0 to 2 meters. The zone will activate if presence is detected for 1 second or longer. The zone will deactivate if no new motion is detected within 1 minute. On the main chart, the zone is highlighted in orange, and in the zone list, you can see that presence is detected in the desk zone. It's important to understand that the main presence sensor works independently of these zones. It triggers when a person is detected anywhere within the general radar detection area, while the zones serve as an additional tool for localization and more detailed behavior control. Let's once again look at the different types of events that the presence sensor detects, depending on the movement type. Left slide. A person is moving away from the sensor. The app shows a corresponding event. Center slide. A person is approaching the sensor. This is also recorded as a separate event. Right slide. A person is standing still but still within the detection zone. Sensor status, active. On the right slide, you can also see how the timeline highlights moments when presence was detected in the first user zone. In our example, table, in orange. This clearly demonstrates how the sensor distinguishes movement types and registers not only the fact of presence, but also the object's dynamics. Now let's take a look at the light level objects reported by the sensor. Left slide, low light level, triggered when the value is below 10 lux. Center slide, medium light level. By default, this is set in the range from 10 to 100 lux. Right slide, high light level. Bright light starts from 100 lux and above. These thresholds can be configured manually in the app, depending on your room conditions. This gradation of illumination allows you to implement flexible automation scenarios, such as turning on the lights only in low light conditions, or dimming the room in case of excessive brightness. The app includes built-in automations, called routines. Each routine can consist of 2 required blocks. Trigger, the event that launches the routine. This could be, for example, presence detection, a change in light level, or activation of a specific zone. Action, what happens in response to the trigger. This might be turning on a light, sending a notification, executing a command via the IR blaster, etc. There is also an optional condition block. Condition, an additional restriction that must be met along with the trigger for the routine to execute. For example, a specific time of day, light level, or the state of another device. Now let's look at where exactly our sensor can be used in these routines. In the triggers section, both sensors are available, presence and light. For the presence sensor, 5 types of triggers are available. General presence detection, triggers when movement or presence is detected in any part of the sensor's coverage area. For separate triggers for each user-defined zone. Trigger when presence is detected in a specific zone that you have pre-configured, e.g., desk, sofa, etc. This allows you to create both general and localized automations tied to specific areas of the space. For the light sensor, the following triggers are available. When a specific light level, dim, normal, bright, is reached, you can choose either an increase to one of the levels or a decrease to one of the levels. Lux values are not shown here. As in the trigger section, the conditions section also includes values from the presence and light sensors. For the presence sensor, you can select General Status. Presence is detected throughout the detection zone. Individual zones. The condition will only be valid if presence is detected in a specific user-defined zone. For the light sensor, the following comparison options are available in the conditions section. Greater than, less than, or equal to. These conditions can be applied to one of 3 preset levels: dim, normal, or bright. In the Actions section, under the current configuration, when the remote is added for Home Assistant, no actions from the app are available. The options list is empty. However, if you select the Use in App option when adding the remote instead of using it in Home Assistant, then actions for sending IR commands will become available in the scenarios. For example, turning the TV on or off, sending operation parameters to the air conditioner, and so on. Thus, routines in the app can use the IR blaster as an actuator, but only if the remote is added in app control mode, not via mqtt and Home Assistant. The device is truly unique and, considering its cost, offers more than a decent feature set. It combines several components at once. A full-fledged infrared blaster, a sensitive presence sensor with flexible settings and support for zone separation, and a light sensor that allows for precise reactions to changes in lighting conditions and can be used in automations. One thing to note, as of now in Home Assistant via mqtt integration, the user-defined zones configured in the app unfortunately are not passed into the system as separate entities. This can be considered a limitation, as such functionality would significantly expand automation capabilities. On the other hand, the zones can be implemented manually using template sensors. For example, you can create a condition where the presence sensor is active and the distance to the object is less than 2 meters, and thus recreate the first zone. Still, it would be preferable if zone data were transmitted natively, directly through mqtt integration, without the need to manually define logic and link different parameters in Home Assistant. That's all. I hope the video was interesting and useful to you. I'd appreciate your likes. They help promote the video on YouTube. If you don't want to miss new content, subscribe to my channel. In the video description, I'll leave links to all the resources mentioned, as well as to my Telegram channels, social media accounts, and smart home discussion groups. Join in, it'll be interesting. Thanks for watching. See you next time. Peace to all.